Okay, so we have a couple people in here who are in Algebra 2. I'm going to ask, think about the answers, don't shout them out. Cool. So we just did a big factoring section in Algebra 2, but again, I think that if we don't do this a couple times throughout the year, you're going to be at a disadvantage. So you should, if you would rather use this time to work on your Algebra 2 cheat sheet, I have no issue with it. Okay, so that's what I just asked you. All right, so easy question. You guys spent several weeks, if not months, on it last year. What is factoring? Yep, not you. What is factoring? Chat with your neighbors. What even is it? Because you guys have done a ton of it. If you answer this question. Go quick. Hustle so that... Nope. He can fill Sonny's. We're not going to go make Vincent wait 10 minutes out in the hallway filling everybody's bottle. Yeah, for you. All right, so coming back together, what is it? So two things or more things do wind up multiplied together. I definitely think that's part of it. If you want to try, you can. I shut down Sunny a minute ago. All right, factoring. All that this is breaking something down. And I'm not going to say something. I'm just going to say breaking down into its parts whose product is the original. Now, this is kind of a blah wording, but we break something down into the parts whose product is the original. And there's two things, really one big thing that we need here. What does product mean? Answer to multiplication. So, Relly, you were spot on with that. Multiplying, yes, we need to multiply. Now, when you guys think of factoring, you probably, and I hope you do, remember factoring in Mr. Russell's class last year. Like, I imagine you do, or I don't remember your math teacher's name, or Jarvis's class last year, you guys also factored. The good news is me, Jarvis, and Russell, while we might write stuff a little different here and there, we do the exact same thing. Now, there is a lot that goes into factoring, and we're not going to spend like 4 days on this right now, just so you're aware. We're just going to try to review a little bit today, maybe tomorrow. Now, you guys all saw factoring last year. Had you ever seen it before at Algebra 1? Yeah. You have. So, for this, my guess is that the first time that you truly see factoring probably happens in 4th grade. 4th or 5th grade, somewhere in there is the very first time that you factored. It could even be before that. I'm just closing this because it's going to distract me. Okay. Nope, guarantee you were factoring in 4th grade. Like, it's different, but check it out. Okay, we're going to start at like that 4th grade-ish. That it's been a while. If you struggle with this, I can help. I want us to factor the following. Okay, and we're going to start in at like super low level. Check it out. 18. I want to factor the number 18 into its prime factors. Now, this language probably is not what you used. My guess is you were told to build a factor tree. Okay, so let's build a factor tree together. There are a few answers that are fine here. There's no best answer. The only bad answer here is 1 times 18, because that doesn't add anything. Can anybody give me 2 numbers that multiply to be 18? 2 and 9. Now, I'm going to write this like this, 2 times 9. If somebody had said, wait, I said it was 3 times 6, you're still cool. Like, you're good. We'll clear it up. Now, for this, right now we have 2 factors of the number 18 on the board. What's one of them? 2 is one of them, and the other one was 9. Now, we're not done, though. Does 2 break down any further? And the fact that it doesn't means it's a what type of number? Prime. Okay, so it comes along for the ride. Does 9 break down any further? How? So if we wanted to go all the way down, do you agree that this is the prime factors. 2 times 3 times 3. Okay, is there a better way that one could write this? Okay, do we all agree that this is still the same thing? Okay, the most important thing that I'm going to say, and you'll hear me say something similar to it, these are all the same thing. These are all ways to write 18. Every single one of these. This is 18, this is 18, this is 18, this is 18. We are just writing it so we can see what was made to multiply to get to it.
Like the 1 and 18 and then 2 and 9, like put the line over.
So we don't need to do that yet. We could, I think. Okay. Do you guys remember doing these at some point in your past? What grade is for somebody who remembers? Like that's a guess for me.
Like 3rd or 4th grade.
Okay, so I want you guys to do 2 more for me. I want you to give me the prime factorization, which is this very smallest prime numbers of 45. And then I also want you to do it for this one. Okay, talk with each other, build your factor trees. If you need a calculator, it's okay. Like you can use a calculator for this. I don't mind. I would start with the biggest number that you are aware of that goes into it. How do we factor 45? 9 times 5 is a good way to go. What if I said, nope, I disagree. I see 15 times 3. Does that mean I'm wrong? No. Now, definitely not whoever said yes. Don't change yours. If you did 9 times 5, keep it. Because let's see what happens. Does 15 break down further? How? So even if I did 15 times 3 first, I wind up with 5 times 3 times 3, which is exactly what you guys had if you did 9 times 5. We get the same thing, right? Doesn't matter how we break it down. If we wanted to do it all the way, bless you, this is just 5 times 3 squared. Bless you. Okay. Feeling okay here? These are all just different ways to write 45. All 3 of these. All 4 of them, rather. Okay. What about 101?
1 and 1.
So if it's only 1 in itself, you haven't added anything other than that's a definition of a certain type of number. This is prime. It doesn't feel like it in my head for whatever reason. There is no nice number that goes into 101 other than 1 and itself. Okay, the prime numbers. There's a lot of them, infinitely many. Okay, what's the first prime number? It's not 1, it's not 0, it's 2. 1, because definition is it has to have 1 and itself. If it's just 1, that's not 1 and, like it is, but it doesn't mean anything. Okay. 2 is the first prime number. What's next? 3. And then? And then? Keep going. 11, 13, 17, 19, 23, 29. Okay, we have a few of them. I don't really care if you know how many of them you know. Cool. All right, this is what factoring looks like in middle school. We're going to get bigger. Okay, so there's only a few different steps that we're going to look at today. I'm going to write another name of an example here, and I want you guys to tell me if you know what it means. That is the greatest common factor. Now, we are not solving anything with these. We are just factoring. We're going to build up our complexity here as we go. So on A, let's say that we have something, and I want us to factor something chill, 2x plus 6. Now, there's a few different approaches that you can take to factoring stuff. We can do it really, really full of work, not so much with this one, or we can start to make sense of it. What do they both have, for sure? They both have numbers. Do they both have variables? No. The 2 has a variable, right? The x changes, it varies, but there's no unknown value here. Okay, so what I would suggest when we think about factoring, especially when we're doing GCF, I would do number to number, variable to variable, if possible. Is there a number that goes into 2 and 6? So 3 won't work, but a 2 will. Now, here's where I'm going to rely either on your memory or just that you don't recall, and I'll address it a different way. When I think about taking a 2 out of this, my suggestion is I want to imagine that I'm factoring it out, because that's what I'm doing. Instead, have you guys ever been told to think about like you're dividing it? Okay, so is it by me? Okay, so I think of it as dividing. When people struggle with it, if I took 2x and I divided it by 2, which came out front, what would be left? X. Now, the other way that you can think about this is if I took a 2 out, what do I multiply it by to get 2x? But because multiplication and division are really the same thing, it just sounds like a different question. Okay, if we took this and divided it by 2, what did it leave behind? 3. Now, do these look very different? Absolutely, they look different. One of them is in factored form. One of them is not. Which one's factored? The red or the black? The red one is the completely factored form of this. And here it is. We're done with it. Okay, let's do a little bit harder one. Cool. We just factored just now. Now, all we did was take out the GCF, which is fine. But let's do another one. This time, we're going to bump it up a bit. X cubed plus 2x squared plus x. Okay, in this, if you look at this and automatically your brain goes, nope, I don't like it, I ain't doing it, I have a way to make it look nicer. I don't want you to do this every time, but it can help. What does x cubed mean? So x times x times x. I would never advocate for you writing it like this every time, but for the first time, I think it's valuable to see it. If I wanted to rewrite this, could I say that x cubed is x times x times x? Okay, plus, I have a 2 times x squared, and there's a 2. What does x squared mean?
X times X.
2 times x, and then finally, plus, it's just x, right? If I write it like this, and it takes a lot of extra time to do this, which is why I wouldn't advocate it for, but I do think it becomes a little bit more clear to see what they all have. Is there something that each one of these has? If I take an x out of this, I can do it, and this, I could do it, right? So all that means is we'll go ahead and factor an x out of it. If I took the x out, and I'll use this brighter color because it makes it a little bit more clear, what stayed in here?
X squared plus 2x plus 1.
X squared, because it's x times x, plus, now we only have 2 times x, and this one's weird because it really was 1 times x plus 1. Okay. You can always check if this is correct or not. My hope is that we don't have to write it out like this every single time, and here's a way we can check. Factoring and foiling are just opposite directions. They're the same idea, just different ways, just like adding and subtracting are opposite. If I were to distribute back through, and we don't have to do it all out, but we can use it to check. What's x times x squared? X cubed. And if we distributed to this 2x, would we get 2x squared? And if we distributed to the 1, would we get plus 1x? I can see it's the exact same thing. One of them is just in a slightly factored form. Now, that is just GCF that we're doing here. Should we do one more GCF, or are we ready to bump it up a little bit? Okay, so if you're in my Algebra 2 class, we are going to approach this differently because it's like you did in Algebra 1. There's a whole lot of shortcuts that exist within these things, and they all stem from being able to do one idea. Okay, so I will hook us up when we get through everything, and depending on how far we get today, we might continue with this tomorrow, but we'll see. We're going to do an example, and we're going to skip some of our shortcuts, and we're going to talk about factoring by grouping. Factor by grouping. Does this ring a bell to you guys? Okay, now I'm going to use a word that is not a real math word, but it works nicely in this setting. We are going to use factoring by grouping as follows, and we're going to write this out, and I want you to tell me what seems kind of weird about this. Okay, so let's say we had x squared plus 7x, and we'll say, I don't know, minus 8. Now, nothing looks weird about this because I forgot that I was going to do that, but that's okay. Okay, as we run through, up at this point in time, we only have 2 things that we're going to check, and really 1. Is there a GCF between all 3 of those terms? So 1 is always going to be an answer. We're just going to change if I'm saying, is there a GCF, I'm only asking other than 1, because every single, no matter what you give me, will have 1 as a common factor. Anything other than 1. Okay, a lot of people are looking at me like, well, you tell me. There isn't. Does anybody not understand why that's the case? Does this one have an X? So it can't be something with an X. Does this have a number on the front of it? I mean, we didn't write 1. It's a 1. But between 1 and 7 and 8, nothing goes into all 3 of those, right? Like, we just checked every possibility. Number to number, variable to variable. All right. Now, this one, we never write this, but I'm going to write it in this one particular circumstance. What's the number in front of x squared that I just don't write? 1. Okay. It's at this point here in just a moment that I imagine everything is going to come flooding back. I'm going to take this leading coefficient, is what we call this. It happens to be a 1, and I'm going to multiply 1 times -8. What does that give me? -8. Now, here's the weird part of this, and I'm going to write this out way more than maybe everybody needs, but if you need it, I would encourage you to write it. We, at this point, and I'll just write it here, we need 2 numbers that multiply, and I'm just going to say mult, to -8, that number, and simultaneously, and add to, what do you think mult is short for? There it is. We need 2 numbers that multiply to be -8, but they add up to a +7. And right off the bat, my question for you becomes, why did I pick +7? It's this term right here. Okay. Now, for these, with small numbers, it's easy-ish. If you are good at mental math, this is probably going to be easier for you, but here's my suggestion. When you're trying to find these, do it systematically. This is a small number. We need a way to check these reasonably well. First thing, does 1 and 8 work? So I might have laid a trap for you. I have a mistake here already.
No, it's not negative.
One of them has to be negative, right? Now, when they add up, it has to be a positive. Should I make the negative the bigger number or the smaller number? Smaller. Now, these, whether you write them or not, is up to you, but I always think through and I always start at 1. Like, I run through very specific order. I start at 1. Do these add up to +7?
Yeah.
Well, that worked out right away. Okay. For this, there is a shortcut that exists. We're not going to use it. What we will now do is try to rewrite this. And we're not going to change it other than how it looks. We will rewrite, and this is my informal language. This thing has how many terms?
3.
It's a trinomial. Do you guys remember that?
Yeah.
Okay, I'm going to use lame language. I'm going to call it a 3-nomial for now. Okay, we are going to rewrite our 3-nomial as a 4-nomial. Now, I'm only using 3-nomial instead of trinomial, so I can use 4 instead of tetra, because if I talk about a tetranomial, you're probably not going to be super comfortable with it. Check it out. We rewrite the 3-nomial as a 4-nomial using the numbers we found. Okay. Now, you will hear me when we see these again. I'm going to refer to these as my magic numbers, just so you know. There's nothing magic about them other than they make us do this nicely. Okay. What are the 2 numbers that we just found that did that fancy thing? -1 and 8. So check it out. I'm going to rewrite this trinomial, and I'm not going to leave the 1 in front anymore. It's x squared plus, and now we're going to use those other numbers. I'm going to write plus, do you want me to write plus 8x or plus a -1x? Okay, so plus a -1x, and notice I'm just using this number, -1x right here. If you want to put the 1, you can. Plus, what was the other magic number I found? 8. And check this out. We're going to pause here, and I need to make sure that, Klein, if you don't catch what's going on, I don't know what you got. Do you need a pencil also?
Oh, no, I was giving it sort of back.
Okay, deal. So check it out. That's a natural question because this is the part that feels weird. This looks way different, right? But just chill out for one moment. If we combined these back and simplified it down, what would this middle term in red become? Which is exactly what it is. Does this still say x squared plus 7x minus 8? It's written differently, but it still has everything the same, right? Okay, here is, like, in that is our magic. That's what we need. Now, the cool thing that was never clear to me with my teacher, this order doesn't matter. You could call this 8 and negative 1, and you could have written plus 8x and minus 1x, and you would have been okay. We are going to introduce groupings around these, ensuring that we have a plus sign in between them. We have to have the plus sign in between. Now, the whole point of writing this four-nomial was to be able to do this. Is there a GCF in this first group now? What goes into this? Okay, what I want you to do is on the next line, take out the x and rewrite just that first group. X times, I think it's going to be x minus 1. If we take out an x, it could be x plus negative 1. I'm just going to call it x minus 1. And I'll just double check. If I distributed, I'd get x squared minus x. That is correct. Have I lost anybody here? Okay, last little piece. When we look at this, the deal that I want to be able to attain here is I want the same thing, the same set of x minus 1 written on this side. Is there a GCF on this? What? If I write plus 8, if I factor out an 8 here, and it's a positive, what would it leave inside? X minus, not 8, 1. Now, at this point, it feels like magic because it looks so strange, and I'm going to rewrite that so it doesn't look as bad. But as we look at this, let me write that a little nicer. Here's the big takeaway. Do these match? Yep. This tells me that I'm correct. This is one of my factors, x minus 1. Now, what's weird about this is that our other factor is hiding, and it feels like magic unless we see where it really works. Do we have 60 more seconds? Oh, yeah. Here it is, and here it is. Okay, now we have just successfully factored this out. Where I struggle with this, and where I always struggled, was if I write this, and this is done, like this is a correct answer, and I want you guys to help me as you're packing up. You don't have to write this down, because this step feels like magic to me. Like, I never understood it when I was your age. If I were to do this, and I wanted to multiply them, how would you do it? Would you guys do these lines? So notice that what we just did. If we were to FOIL this out, we just took x, and we just are multiplying it into x minus 1. Do you agree with that? When we do the 8, we're taking a positive 8, and we're multiplying it into what? X minus 1. These two forms move back and forth between each other. Tomorrow, we're going to do one more day of factoring stuff and algebra review before we start. There's no additional homework tonight. Gian and Rogue, let me know when you want to take your Chapter 2 test. It could be tomorrow if you want. Yep, I got you. I will right now. Yep. Rogue, swing by right after school. I got to print another one, okay? Gian, same thing.